Hello friends, welcome to our YouTube channel. In this series of basic process engineering calculations, today we will focus on how to calculate the density of multi-component reaction mixture. Okay, as most of the cases we don't have the density or the viscosity data for the multi-component reaction mixture, so these required for the precise calculations that may be related to the energy balance or the mass balance. Okay, so today we will focus on how to calculate the density of such a reaction mixture. For example, I have considered there is a reaction mixture of couple of solvents. First is xylene and another is acetic acid. Both we have the reaction mixture. So here first I will take the quantity mass of xylene in reaction mixture. Then we need density which is standard density of xylene. Then mass of acetic acid in reaction mixture, whatever we considering. Then density of acetic acid. Okay, so we have these data. These are the standard data, and you can get it from the uh, Google also. This is the quantity I have assumed for the calculation here. So you can check for the whatever the parameters or the components available with you. Here for the xylene density, we can get it from the MSDS of xylene. It's in 870 kg per meter cube. Then density of acetic acid. Okay. Now we have the standard density of the components and the quantity of materials available in the reaction mixture. Okay, so first we uh, before going to calculate the mixture density, we need mass fraction of each component. Mass fraction of xylene in reaction mixture. Okay, and same we needs to calculate for the acetic acid also. Okay, CTI reaction mixture mass fraction of acetic acid also. Okay, so now we just calculate the mass fraction, as you know how to calculate mass fraction. Okay, so here we are calculating mass fraction of xylene. Simply multiply its mass into density, divide by the mass into density of xylene, plus the mass into density of acetic acid, as we are calculating the mass fraction. Okay, so mass fraction whatever available with us for the calculation purpose. Okay, so here we have the mass fraction of xylene in reaction mixture, which is like uh, 0.3016. Then we can simply minus that mass fraction from 1, so we get the another component mass fraction. But here we calculate again 4.8 into this, so that you will get the clarity about how to calculate the mass fractions. Okay, then again we have to take the mass fraction, so we'll get the different mass fraction. Here is the mass fraction of acetic acid in the reaction mixture is 0.6, and the mass fraction of xylene in the reaction mixture is the 2.3. Okay, so now we have all the data, so we calculate the density of reaction mixture. Okay, so to calculate that, we need the simply 1 by the mass fraction of the xylene which we calculated. Okay, here we simply calculate the mass fraction of xylene calculated divided by the density of xylene. Okay, plus same for the mass fraction of the acetic acid divided by the density of acetic acid. So we got the density of the multi-component mixture which is contained acetic acid and xylene are the components. So based on that, our calculated density is here. So you can check for the number of different compositions also. So here I just add another component, so you'll get the more idea. Okay, so here mass of component 3, so we called it component 3 is 2.8 meter cube. Okay, so now we assume its density of component 3. So density of component 3 is 1540 kg per meter cube. Okay, so now we have to calculate the same mass fraction for the component 3. Okay, mass fraction of component 3 in reaction mixture. Okay, so simply we, so now here are calculated mass fractions for the both the component will get changed. Okay, as there is another one component is there, so we add its volume into density, so we'll get the change in component mass fraction here. Okay, so same for the case, plus 2.8 into its density which is 1540. So here is the calculated mass fraction of the acetic acid is going to change. So we calculate in similar way the mass fraction for the component 3 by simply multiplying its density into the mass. As there are 3 components, so we have to do for all the components in similar way like we have performed for the xylene and acetic acid. Okay, so here is our calculated mass fraction of the component 3. So now we have the 3 component mass fractions available, so we can calculate its density by, okay, so here to calculate the density of the reaction mixture we have to add the same mass fraction of third component divided by its density, so we'll get the calculated density which is 993 kg per meter cube. So in the similar way you can calculate the whatever reaction mixture you have, so you can calculate its density with using this simple Excel spreadsheet. Hope you understood this. If you have any doubts, you can drop me a message in a comment section, or you can simply mail me on the mail ID provided in the channel link. Thank you for now.